Understanding vector algebra. So let's start with a new thing now, which is relating point-to-point vector with position vector. So this video is going to help you understand what is point-to-point vector and how it is related with position vector. AB is a vector whose tail is at -4, 2 and whose head is at -1, 3. Determine the position vector CD if CD equals to AB. So that is first part of our question. And the next part is position of the above vectors is not the same. Even then they are equal. Explain. So we'll answer these questions in this video. Now, point-to-point vector. So a couple of videos which we did before this were relating to point-to-point, and I hope you understand the concept of point-to-point. As the name says, when you say point-to-point, so the vector is defined from tail to head. Tail is the starting point and head is the end point of the vector. So if we say vector AB and we show an arrow like this from A to B, then point A is the tail and point B is the head. So let's first draw the vector AB as we did in previous couple of videos. So tail is at -4, 2. -4 and 2. So that happens to be the tail of the vector AB. And the coordinates of this point will be -4 and 2 as given here. And the point here will be labeled as A. Okay? So it is from A to B. And where is B? B is the head of this vector, which is at -1, 3. So -1 and 3 is this point. So that is the head of the vector, and we will call this B. And if I join A and B and make an arrow at B, that shows our vector. Length of this line shows the magnitude of the vector, and the direction is by this arrow, right? And it goes from A to B. So that is our point-to-point vector AB. Now, we need to first understand what is the meaning of position vector. As you know, vectors have two things, which is magnitude and direction. Two vectors are equal if they have same magnitude and same direction. Position is not of interest, but still here we are talking about a position vector. Okay, so that's kind of funny, right? So what we do actually is that we try to position all our vectors with their tail at origin. Do you see that? And then we get a vector. Now, if I put all the vectors with tail at origin, I can very easily compare them. It becomes easy, right? That's the whole idea. And as you know, all the vectors can be translated anywhere on the plane and they still remain same and equivalent, right? So I will do transformation and show you how to convert vector AB into vector CD with change in position. And basic change in position which we are bringing is bringing the starting point to the origin, right? So let's go. So if I have to get A to the origin, then what can I do? I have to move down 2 units and write 1, 2, 3, 4. So that's the kind of transformation. If I do, I reach this point. That is, move 2 units down and 1, 2, 3, 4 right. So for B, I have to do the same thing. Let's move 2 units down and 4 right. 1, 2, 3, 4. So I get my head also. So this vector is the vector which is a position vector since it starts with the origin, and it is equal to AB since its direction and magnitude is exactly same as AB. Let me call this vector as CD now. So this is C and this is D. So that is a graphical way of getting the answer. Converting point vector into position vector, right? So what we did really was that we changed the position of the tail from the given position to origin 0 0, right? So see the change. So what we did was that we translated this, right, from this point to the point 0 0. So whenever we are trying to convert point to point vector into its position vector, then we are trying to take it, slide it, translate it so that its tail gets aligned with the origin. And obviously, if the tail gets aligned with the origin, then the head will also move or get translated by same horizontal and vertical position, right? So as you can see here, translating from -4 to 0 means 4 units right. And translating from 2 to 0 means 2 units down, right? So from the translation of tail, so in CD, C is our tail, right? So C is our tail. So what we see is that to get to 0 0, what we do? We do -4 plus 4, right? So we are moving 4 units to right, right? -4 is 4 minutes right. That is the X or horizontal translation. And as far as Y is concerned, we are moving 2 units down. That means -2. So we went from 2 to -2. So that is how we got C, right? Now to D, if we have to get D, which will get automatically transferred to the respective position. So the coordinates of D should be, let's say this is my coordinates for X, right? So I'm writing C coordinates are like this, and my D coordinates will also go through the same translation. Earlier it was -1, so it will become, let me write the X coordinates like -1 plus 4, right? That happens to my X point, and the Y point -2 translated 2 units down. So 3 -2. So that is the translated position for D. Now therefore, I can now write my answer, and my answer is that the coordinates of points C and D are, so I'll say vector CD is from the tail, so I'm writing tail first. That means C. I should have written C here. Let's say tail C is -4 plus 4 is 0, right? The whole idea was 0. And Y value is 2 minus 2, 0, right? So it is basically from 0, 0 to D point is -1 plus 4, which is 3. And 3 minus 2, which is 1, right? So for CD, I have tail at 0, 0 and head at 3, 1. So 1, 2, 3 and 1. You see that? So algebraically, we can get the point C and D using translation. Do you see that? Right. So the idea is that the tail will always be translated to origin. That means 0, 0. So therefore, whatever the coordinates are there of the tail, if it is -4 and 2, we have to add 4 and -2 to get the head translated to the respective position, right? So you could do it like that also. So basically, we are translating our vector anywhere given on the coordinate plane to a position with tail at origin. And when we do so, it becomes a position vector. And I hope you will appreciate that when we are talking about a position vector, then we really don't have to say that tail is at origin and head is at this, right? Because it is assumed, right? So therefore, normally, position vectors are referred with small letters, and we will write this, for example, we can write this as a vector C, for example, right? So we say vector C. So we could write just vector C. So we say vector C is 3, 1. So when I say vector C is 3, 1, so let me write vector C here, and let me just write position 3, 1, right? So when I say vector C as 3, 1, it is a position vector whose tail is at origin, we all know, and this is the location of the head. Do you see the 3, 1, right? So that is how now we can represent our vector. So in a point-to-point vector, we need to identify both tail and the head. In the position vector, we know that by default, tail is at the origin. So it is only identified by its head position. And normally, we use capital letters like A, B vector as we have shown here for point-to-point vectors and lowercase letters for position vectors. Okay, so that is, I think, helps you to understand what a position vector is and how you can translate point-to-point vector to a position with tail at origin and get the coordinates and thereby define the related position vector. I hope that's clear. Now part B of this is position of the above vectors. As you can see, A, B and C, D is very different, right? But still they are equal. So for a vector, we are comparing only two things, magnitude and direction. As you can see, both magnitudes are same and both directions are same. Therefore, they are equal. Now as an added exercise, I will appreciate if you could find magnitude and direction of vector AB, right? And compare it with that of CD, right? So that should answer this question. I hope that's absolutely clear. Now based on this, I have put two questions following. So try to do those two questions. If there is a difficulty, come back to this, right? And then get over. Then I'll again move further with point-to-point and position vector. I hope you are enjoying this process of learning, and please do appreciate your comments about this. Your feedback is highly appreciated. Thanks and all the best.